Hi and welcome. This tutorial will provide the internals or features of Intel's 8051 and Atmel's AT89S52 microcontroller. If we consider the features of a microcontroller, then we can divide it into several parts such as the package type, the number of pins, available on-chip ROM and RAM, available registers and SFRs, power supply requirements, clock speed and many other features. The 8051 was introduced in 1981 by Intel, and the Atmel's 8051 is having the similar features of original 8051, but some capabilities are extended in Atmel's 8051. So first I will discuss the common features of 8051. First of all, it is available in plastic dip package. The microcontroller is having 32 pins arranged in 4 ports, which are known as port 0, port 1, port 2 and port 3. The original 8051 was introduced with 128 bytes of RAM for data storage and internal 4 kilobytes of ROM for program storage. There are two 16-bit timers in original 8051 and 6 interrupt sources including software and hardware interrupts. The universal asynchronous receiver and transmitter is available for serial communication. If I consider the CPU registers, then there are 4 register banks and each bank consists of 8 registers from R0 to R7, and there are 2 special registers, accumulator and register B. All the registers of 8051 are 8-bit wide. There is also an on-chip oscillator, which is a source to provide the clock to the microcontroller. The 16-bit program counter of 8051 is also known as PC, and it is capable to address on-chip 64 kilobytes of program memory. Along with this, it has a 16-bit data pointer register also known as DPTR and 8-bit SP or stack pointer register. The system clock of standard 8051 is divided by 12. That means if we are connecting a 12 MHz crystal to the oscillator pins, then it will be divided by 12 and we will get only 1 MHz as a CPU clock. 8-bit program status word register is used to store the flag status such as carry 0 or auxiliary carry flag. The original 8051 microcontroller is supporting 111 assembly language instructions, and it is a CISC-based architecture. The microcontroller is featured with 16-bit address bus and 8-bit data bus to access the external memories. On the other hand, if I consider Atmel's AT89S52 microcontroller, then its memory is extended and we will get 8 kilobytes of in-system programmable flash memory or ROM memory with 256 bytes of internal RAM instead of 128 bytes. So we are getting double the ROM and RAM in Atmel's AT89S52. And there is one extra timer, timer 2 in Atmel's 8051. Now it's time to discuss 8051 block diagram, and this is the very basic block diagram of microcontroller. We have this central part CPU, and this CPU requires oscillator clock to work. We can consider this bus as a system bus because it will carry the data in and out from the CPU towards and from the peripherals. And we have this bus control block here, which will control the timings to read and write the data from the system bus. On the upper side we have this on-chip ROM to store the code for 8051 and on-chip RAM to store the data variables during the operation. We have this block for 4 input-output ports of 8051. The next block is for serial port, which is UART. Here we have timer 0 and timer 1 block, and here we have this interrupt control block. If I consider the CPU of 8051, then it also supports arithmetic and logic operations such as 8-bit addition, subtraction, multiplication, division, ANDing, ORing, NOT, and other operations. There are some special function registers, also known as SFRs, and these registers will enable or disable a special function for 8051. Such registers are timer registers such as timer control and timer mode register, interrupt enable register, serial control register, serial buffer, stack pointer, data pointer, power control, and other registers. There are many points to discuss further, but we will discuss those points in next tutorial. So thanks for watching and subscribe the channel.